Hi guys, okay, so for today, no, let us continue our discussion regarding motion curves. Okay, so last time, no, ang napag-usapan na natin is kung paano kumuha ng mga velocity and then paano kumuha ng mga position, no. So let us just recall, no, let's say for example, nagbigay ng situation, no, given yung relationship nung acceleration versus yung time t, so we can graph that. So, para ma-plot natin tong velocity and then time diagram, no? So, what we need to do is to start, no, given using yung given na initial velocity. And then, para ma-plot natin yung all other points, no, what we need to do is to use yung area ng acceleration time diagram. Okay? So, how do we do that? So, let's say, for example, we have V1, okay, which is at T1. So, in order for us to solve yung V2, no, at T2, so what we need to do is to add yung area ng acceleration time diagram in between T1 and then T2. Kunin natin yung area, i-add natin yan dun sa V1. So, therefore, V1 plus this area will become the V2. Okay? So, that's the relationship, no, which is this one. And then take note that if this one is n degree, so therefore the velocity time diagram will always become n plus 1 degree. Okay, that is 1 degree higher always, no, doon sa acceleration time diagram. Okay? So the same with the position time diagram. So let's say for example, we have position S1. So para makuha natin yung S2, no, at T2, so what we need to do is to determine yung area nung diagram above. So in that case, ito yung diagram above the position time diagram. So kunin natin tong area na to in between time interval T1, T2, and then add that area to S1. So therefore, S1 plus this area will become the value of S2. Okay, so which is this one. Nagawa na rin natin to last time. Okay? So, ganun din, the same case. So, kung ito is n plus 1 degree, so the relationship will become, this one will become a n plus 2 degree, no? So, 1 degree higher than the degree no velocity time diagram. Okay, so plus 1 ang plus 1. So, naipakita ko na rin yun, guys, no, kung paano mag-drawing nung 1 degree higher na curve. So, now, the problem here is that minsan kasi ang diagram, no, representing the acceleration time diagram is medyo, halimbawa, let's say for example, complex na, kung tawagin natin, complex na yung diagram. So kung complex na yung diagram neto, therefore complex nang kunin yung area. Okay? Ngayon, ang magiging problema dito kung gagamitin natin tong ganitong method, so before we can solve yung position, kailangan nating dumaan dito sa velocity. Kailangan i-graph muna natin ito, no? So, para mag-graph natin ito, kailangan natin yung mga area dito. Sabi nga natin, di ba, halimbawa, complex na. So, therefore, magiging mas lalong complex yung diagram dito. So, sana guess nyo yun, guys, no? Kung complex na itong acceleration time diagram, mas lalong magiging complex ito. Where in that case, kung mas lalong complex ito, mas mahihirapan tayong kunin yung position. Kasi mahihirap nang kunin lalo yung mga area. No? So may mga ganong cases, class, no, na sometimes, no, kaka-drawing natin, no, though systematic siya, may certain cases na baka erroneous yung makukuha nating area kasi mali na drawing nating diagram. So ngayon, ang ipe-present ko sa inyo is yung another way, no, to solve yung position without even drawing itong velocity time diagram. Kahit hindi mo na rin ito drawing, no? So, ang kailangan lang natin dito, class, no, sa method na pag-uusapan natin ngayon is yung diagram ng acceleration or yung acceleration time diagram. Okay? So, ito lang ang kailangan natin and then yung mga given na initial parameters. So, makukuha na natin yung position at any time na hinahanap. Okay? So, take note, itong pag-uusapan nating solution, no, is nakafocus sa pagkuha ng position. Okay? Position yung susolve natin. So, ito ay tinatawag as moment area method. Okay? So, paano ginagamit yung moment area method? So, ito yung mga conditions na kailangan meron tayo before we can use itong method na to. Okay? So, kailangan meron tayong initial position. Okay? Always, kailangan may initial position. Let's say, for example, ang given na initial position is itong at time t1. Okay? So, let me highlight that one. Okay, so kita ba? Ayan, hin-highlight ko siya ng dilaw. So, let's for example, ang given na initial position is yung at time t1. So, ang kailangan dito class is dapat doon sa time na yan, merong given na velocity. So, dapat at that time, given yung velocity niya. So, which is what we called here as v1. And then another thing, dapat sa time na yan, given din yung position, which is in this case S1. Okay? So, dapat at T1, merong V1 at S1. So, let's say for example, ang hinahanap is yung position niya, no? Yung position niya after time T, which is ito, at T2. Tawagin natin at T2. So, at T2, tinatanong, ano na yung position ko, no? Pag nasa T2 na ako. So, in that case, ang tinatanong yung S2. Okay? So, ito yung formula guys na susundan natin. So, S2 ay equal sa initial position niya, which is yung S1. Okay? Plus yung initial velocity niya times yung time interval na lumipas between the initial time and then yung final time na hinahanap, which is at T2. So, sana guess nyo ako guys, no? So, in that case, no, ito yung time na yan guys, no? Itong hina-highlight ko, no? Time difference between yung initial time and then yung time T2 na hinahanapan ng position. Okay lang ba? So, i-denote ko na lang siyang ganyan guys, ah. So, that is S1 plus V1 times T and then plus yung moment nung area. So, tawagin kong area moment. So, I think hindi yata kita na. Ayan, kita pa naman. So, plus area moment of the acceleration time diagram between that time interval. Okay? So, as you can see, may area to, no, yung acceleration time diagram natin. Pero yung kailangan lang natin is yung area between T1 and then T2. So, in that case, yun yung highlighted netong kulay red. Okay? So, that is yung area to be considered. Ngayon, saan siya imo-moment? Kasi tinatawag area moment, di ba? So, imo-moment natin siya guys doon sa point T2. No, kasi yun yung hinahanapan natin ng position. No, kung saan ka naghahanap ng position, doon mo imo-moment yung area. Okay lang? So, mag-zoom in tayo dito. So, yun yung pinag-uusapan natin guys, no? Itong kulay red. So, syempre, meron yung centroid and then dapat alam na natin kung paano magkuha ng centroid. So, what we need to do is to take its moment, no? Moment about T2. So, ito yung magiging moment arm natin guys. In distance na to. Okay? So, konting geometry lang yan guys, no? Yan na yung gagamitin nating moment arm, which is in that case, hindi ko na siya pe-present dun sa formula, no? Kasi iba-iba yan, di ba? Iba-iba yung distance na yan. So, that's why pinakita na lang natin siya dito as area moment. Okay? So, i-moment natin yung area at point T2. So, itong distance na to. So, ganun lang siya gamitin guys. Makuha na natin yung S2. Okay. So, ang kagandahan nito guys is that hindi mo kailangan na sa initial point niya, no, sa starting point niya, doon ka magsisimula ng S1. No? Hindi always necessary na yung T1 mo is yung at T1 is equal to 0. Tapos yung S1 mo is yung initial position niya. Tapos yung V1 mo is yung initial velocity niya. Yun yung kagandahan nito guys na hindi required na doon ka magsisimula. So that's why sa pinakita ko dito, okay, sa drawing ko, is that yung T1 ko is nag-start na ako at any arbitrary time T, no? So, hindi ako nag-start at 0 para general yung discussion. So, yung T1 ko, let's say for example, hindi dito na siya. So, meron na siyang velocity and then meron na rin siyang position S1 na hindi 0. Okay? So, yun yung sinasabi ko guys ha. Paki-take note lang na you can start at any point so long as given yung position niya at yung velocity niya at that time. So, para mas magets natin to guys, no? Meron kasi akong isang sample problem na hindi pa natin nasagutan pero before we proceed to that, no, sagutan muna natin yung mga previous items natin using this solution. Pero yung sasagutan na lang natin yung position kasi pang-position lang to guys, di ba? So, yung mga questions lang na nagtatanong ng position, doon lang natin to gamitin. Okay? So, kunin muna natin yung last problem natin. So, ito, situation 10. Okay, so wait lang guys. Okay. So, apply natin dito guys, no? So, the car starts from rest and travel along a straight track such that it accelerates from 10 meters per second squared for 10 seconds and then decelerates at 2 meters per second squared which is represented na netong acceleration time diagram na to. Okay? So, let's assume na nasagot na natin itong time t na to na tumigil siya. So, which is 60 seconds, no? Para madali lang yung solution natin. So, I will just redraw. Okay, so ito yun, 10. So, for example, yan na siya, no? Acceleration time diagram. This one is 10. This one is negative 2. So, this one is after 10 seconds. And then, let's say, for example, nakuha na natin nga ito. This one is after 60 seconds. Okay? So, ang po-focusan na lang natin dito is ito, no? How far has the car traveled? Or tinatanong, what is its position after 60 seconds? No? Kasi doon na siya tumigil, di ba? After 60 seconds. So, ano na yung position niya after that time? So, ang first step, no, is to determine yung time T1 saka time T2. So, yung time T2 is always yung time na hinahanapan mo ng position. So, in that case, yung T2 natin is itong after 60 seconds. No, ito yung magiging point 2 natin. Okay? So, ngayon, hahanapin naman natin yung point 1. No? So, take note dapat yung point 1, ang criteria is dapat meron siyang S1 saka V1. Okay? Which is dapat given or solvable. So, wag natin pahirapan, gamitin natin initial point. No, point 1 is yung starting point niya. Okay. So, let's use this one as our point 1. So, now, pakita lang natin no, lahat ng parameters. So, what is yung T1 doon sa pinili nating point 1? So, syempre 0. So, what is yung S1? Ano yung position niya at that point? No? So, wala namang sinabi sa problem. So, let us assume na nag-start siya at 0. So, what is its velocity? No, at that point? So, sinabi, the car starts from rest. No? So, therefore, this one is 0. Okay? So, next sa T2 tayo, or sa point 2 tayo rather. So, at point 2, what is yung T2? So, this one is 60 seconds. So, ang hinahanap natin dito is yung S2, no? Yung position niya at point 2. So, hindi na natin kailangan yung V2 kasi hindi naman siya kailangan dito sa formula. Okay? So, now we can use directly na yung formula natin. So, that S2 is equal to S1 plus V1 times yung time T or yung time interval T, which is, that is always yung T2 minus T1. Yun na lang lagay ko dito, no? So, lagay ko to dito para clear. Ito is T2 minus T1. Yan yung time interval t. Okay? And then plus the area moment of the acceleration time diagram. Okay? So initially, nasa 0 siya. And then initial velocity is 0. And then times 60 minus 0. And then plus the area moment na agad. Okay? So as you can see, we have here two areas. Now, one is positive and then one is negative. So what we need to do is to just take its moment, no, about 0.2. So syempre, this one, anong area nito guys? 10 times 10. So 100. This one is what? Area is, so yung length na to is how much to guys? So kung 16 total, 10 ito, therefore ito ay 50. Therefore base times the height. 50 times the height is negative 2. So therefore negative 100. So of course, marunong ka na dapat kumuha ng centroid. So centroid, centroid. So therefore moment arm. So this one is the moment arm. So how much is this guys? How much ito? So that is, this one is 50 plus kalahati ng 10. So therefore 55. Okay, ito. How much ito? So ito is kalahati lang ng 50. So this one is 25. Okay, so i-moment lang natin sila. So let's start with the positive area. So that is 100 times the moment arm is 55. And then plus yung negative area. So lagyan lang natin negative 100 times the moment arm is 25. Okay, so using this equation, we can directly solve yung S2. No? As you can see, wala ka ng additional diagrams na dinagdag pa, no? Hindi ka na nag-isip nung kung anong increasing slope, decreasing slope, anong degree. So, directly masolve na natin yung position niya doon sa hinahanap na or doon sa given na time, no? So, how much is that, guys? So, that is 3,000, no? So, 3,000, so in meters. So, from the choices, that is correct, no? 3,000. Okay? So, na-appreciate nyo ba, guys? Yung paggamit nung, nung moment area method or area moment method, no? So, next, eto pa, no? Apply rin natin siya dito, guys. Situation 11. So, basahin nga natin, guys. A car accelerates from initial velocity of 10. So, the acceleration is increasing uniformly from 0 to 8 meters per second squared in 6 seconds during the next 2 seconds. The car decelerates at a constant rate of 2 meters per second squared. So, ito yung diagram nun, guys, no? So, initially, nasa 0 yung acceleration and then increasing uniformly up to 6 seconds. So, ito yung 6. And then, at 6 seconds, that is, na siya, 8 meters per second squared. And then, after that, no, 2 more seconds, nagde-decelerate na siya ng 2 meters per second squared. So, ito yung, acceleration time diagram natin. So, ang tinatanong is determine the distance traveled, no, after 8 seconds. Okay, so distance traveled after 8 seconds. Okay, so copy ko lang muna siguro, guys, no. Okay, and then let us just redraw. So, let's say for example, ito yung 6. Ito yung 8. So, increasing. And then, constant deceleration. Ayan. So, this one is negative 2. This one is 8. So, this one is the acceleration time diagram. So, ang tinatanong is yung position niya after 8 seconds. So, definitely this one will become our point 2, no? So ngayon hahanapin natin yung pinakamagandang point 1. So sino ba yung may given class? Ang may given class kadalasan itong initial point niya, starting point, no? So let us just use this one as our point 1. So define natin what is T1. So siyempre 0. What is S1? So may sinabi ba? Walang sinabi, no? So let us assume na nag-start siya at the origin. And then what is V1? Wala bang sinabi? Meron. Ayun nga, naka-highlight guys, no? The initial velocity is 10 meters per second. So 10 ito. So at T2, kita pa ba? Okay, kita pa. So this one is after 8 seconds. So what is S2? Ayun ang tinatanong. So ano nga ulit ang formula? S2 equals S1 plus V1 times the time interval T and then plus the area moment of the acceleration time diagram between that time interval. Okay, so let us start. S1 is 0. V1 is 10. And then what is yung time T? So that is the difference, no, nung time T2 minus yung time T1. Okay, plus the area moment. So as you can see, between point 1 and point 2, may dalawa na naman tayong area. Okay, so one is positive, the other one is negative. Kunin muna natin guys yung area. What is the area of this one? 1/2 base times the height. Base is 6. Height is 8. So therefore, this one is 24. So for this one, what is the area? Base is 2. Height is negative 2. So negative 4. Okay, so lagay nga natin. Yung distance na to is 2. So, let's start with the positive area. So, that is 24. Ano yung moment arm, guys? So, ito yung centroid niyan. So, from point 2, okay, how much is this distance? So, that is what? This one, no? This one is 2, and then plus yung 1/3 na itong pa, no? Nung base. What is the base nito? 6, diba? So, 1/3 nung 6, lagay nga natin. 1/3 nung 6 plus 2. So, this one is, I think, 4. Tama ba, guys? So, 4 yan. So, lagyan natin 24 times 4. Okay? Plus yung moment ng negative area. So, ito yung centroid. Okay, so yung distance is 1. Okay, so lagyan natin minus 4, yung area, times 1. Okay? So, what is now yung S2? So, sagot is 172 meters. So, as you can see, tama siya from the choices. And then nakikita mo, class, no? Direct to the point, no? So, kung babalikan natin yung previous solution natin, meron pa pala tayong mga ganito, no? Nag-analyze pa tayo ng different types of spandrel. And then, ano yung mga general formula. Okay. And then, meron pa akong, I think, na pinresent dito, no, nung limitation ng paggamit ng spandrel, no? Kung kailan lang siya nagagamit. So, sana nasundan nyo siya dito, guys. As you can see, mahaba yung solution, no? Unlike ito, ang bilis lang. So, yun lang naman yung kagandahan niya, guys. Okay? So, before we proceed no do sa last item natin, so let us just try to solve this one. No, gusto ko pa siyang i-solve pa ulit, no, tong situation 11 using different point, no? So, sabi ko nga kasi yung applicability nung formula is hindi naman siya palaging kailangan yung point 1 mo yung at times equal to 0. No, you can start at any time t1 so long as alam mo yung S1 doon saka yung V1 doon. Okay? So let's say for example, alam natin ito, no. Ganito yung gawin natin, guys, ha. So di ba ito naman always yung point 2, yung after 8 seconds. So let's say for example, alam natin tong parameter dito after 6 seconds. Ito yung gamitin nating point 1. So therefore T1, okay? So ayusin lang natin. So, magiging T1 natin is 6, di ba? So, ano na yung velocity mo at that point, no? At after 6 seconds. So, tingnan natin dito. Let's for example, alam natin yan. Ito yan, no? Nasa baba, guys. So, yung velocity niya at this point is 34. Ayan yan, guys. So, lagyan natin 34. Ano yung S1, guys, no? At 6 seconds. So, check natin pababa sa graph. Ayan, nandito tayo sa 108, no? 108. So, tatry lang natin, guys, no? Kung totoo yung sinasabi ko na we can start at any point doon sa graph, no? Not necessary na mag-start ka sa 0. So, let's say, for example, nag-start tayo at 6. Tapos, ito yung T2 natin. After 8 seconds na. Ano yung S2? So, using the same formula, S2 is equal to S1 plus V1 times yung time interval T plus the area moment, no? Nung acceleration time diagram. So, ano yung S1, guys? So, nag-start tayo at 108. Ano yung V1? So, 34 na siya at that point. So, ano yung time T? Time difference, that is 8 minus 6 or after 2 seconds. And then plus, ano yung area moment? So, ang pag-uusapan nating area is yung area between point 1 and then point 2, which is this one. Okay? So, yung area niyan is, eto na yan, negative 4. So, ang centroid niyan is ito, distance is 1. Okay lang, guys, naka-follow. So, lagyan natin plus area moment, so negative 4 times 1. Okay? Ito lang yung pinag-usapan natin, guys, na area, no? Yung area between dun sa point 1 and then point 2. So, using this equation, so, tama ba? Verified ba na yung S2 is 172? Patry naman, guys. Okay, no? So, that is still correct. Okay, so ganun siya kaganda, guys. No? Okay, so sana na-appreciate. So, kung gets na, guys. Kung gets na. So, let us now solve, no, yung last situation for this topic. So, kunin ko lang, guys. Okay. So, ayan, guys. Last item na tayo. So, situation 12. So, the acceleration time curve for a particle having a rectilinear motion is shown in the figure. At time is equal to 0, the velocity is 8 feet per second and the particle is 60 feet to the left of the origin of displacement. So, using this diagram, so determine the velocity when time is equal to 4, determine the displacement when time is equal to 7, determine the displacement when time is equal to 13 seconds. No? So, mayroong dalawang displacement na hinahanap after 7 seconds and then after 13 seconds. So, let us just try lang na magkaroon tayo ng overview. What if gusto nating mag-drawing nung mga curves, no? Nung velocity time diagram saka nung position time diagram. What if gusto nating mag-drawing? So, copy ko na lang siguro, guys. Ayan. Okay, dito tayo mag-drawing sa baba. So, this one is the velocity time diagram. So, let us plot. So, at time is equal to 0, may sinabi. At time is equal to 0, the velocity is 8. So, mag-start tayo dito sa 8. Okay? So, meron tayong mga given na time. So, after 4, after 7, saka after 13 seconds. Ayan. So, paano tayo makapunta? After 4 seconds, paano natin makukuha yung velocity? So, we just have to add this area. Now, kunin natin tong area nito. So, what is that? Area is 1/2 base is 4, height is 6. So I think that is 12. And therefore, 8 plus 12, 8 plus 12, so that is 20. Okay? So, let's say for example, ito na yung 20. Kunwari lang, ayan. So, yun yung problema, no? How do we connect these 2 points? No? So, since this one is first degree, so dapat dito second degree na. So, curve na siya. So, anong type ng curve? Increasing or decreasing? So, check muna natin. So, eto, nag-start siya sa 0. Nagtapos siya sa 6. So, therefore, 0 to 6, nag-i-increase. So, therefore, ang curve na gagamitin natin is yung increasing, no? From negative slope, papuntang positive slope. So, ganyang curve yung papang-connect natin. Concave, upward. Okay? So, ito yan. Ganyan. Gets? And then, from 4 seconds, paano tayo makakupuntang 7? So, we just have to add the area of this rectangle. So, this one is 3, diba? So, area is, base is 3, height is 6. So, plus 18. Okay? So, 20 plus 18 tayo. So, that is 38. So, let's say for example, dito na yan. So, how do we connect? So, since this one is 0 degree, so ito walang hirap, first degree. Line lang yan. So, first degree, ito second degree. Okay? And then, finally, from 7 seconds, pupunta tayong 13. So, this one is 6 seconds. So, how do we solve for the velocity after a total of 13 seconds? So, from 38, i-add natin tong area na to. But in that case, this area is negative. Okay? So, trapezoid lang, no? So, that is 1/2. Etong base na to, negative 12. Plus, etong base na to, negative 3. And then, times yung distance na 6. Okay, so how much that, guys? That is negative 45. Okay, so from 38 plus negative 45, so aatras pala siya, no? So, lagyan natin dito, 38 minus 45. So, I think this one is negative 7. Okay, let's say for example, dito yun. So, how do we connect? So, since this one is what? First degree. So, second degree ang papang-connect natin. So, what type of second degree? Increasing or decreasing slope? So, saan na siya nag-start? Nag-start siya ng negative 12. Nagtapos siya ng negative 3. So, from negative 12, naging negative 3. So, still increasing. Okay? So, ito pa rin yung curve na gagamitin natin. Concave upward. Okay, for example, pa ganyan. Okay, so second degree. Okay? So, ayan na siya. So, kaya na pala natin sagutan yung velocity, no? When t is equal to 4 seconds. So, that is what? Ito. 20. Okay, ito yan na. Yan. So, walang problema. So, ito yung magiging problema natin, guys, kung itutuloy natin yung ganitong solution. Kasi kung mag-drawing tayo, mag-graph tayo ng position, time diagram. Okay. So, lagyan natin yung mga important points. So, this one is after 4 seconds. This one is after 7 seconds. This one is after 13 seconds. Okay? So, let's start dun sa point na at time is equal to 0. So, may sinabi ba? So, dito may sinabi din na, guys, ha? Huwag kakalimutan na yung sinabi. The particle is 60 feet to the left of the origin of displacement. So, meaning to say, hindi siya nag-start mismo dun sa origin. Nag-start siya from the left. So, kung titignan natin sa Cartesian plane yun, that is parang nasa negative axis. Okay? So, 60 feet, meaning to say, yung negative axis nasa baba siya. Dito na nag-start sa negative 60. Okay lang ba yun, guys? Gets ba yung sinabi ko? So, meron na tayong initial, madali nang kunin yung mga susunod kasi mag-refer na lang tayo dun sa area nung diagram above. Okay? So, in that case, from negative 60, para makapunta tayo sa 4 seconds dito, so kailangan natin kunin itong area na itong curve na to. So ngayon, how do we solve yung area niyan, guys? So naka-curve na siya ng second degree. So dito, madali pa, no? Kaya pa naman to kasi we can divide yung area na to into two basic shapes, no? Isang rectangle sa baba and then isang spandrel sa taas na second degree. So applicable ba yung formula ng spandrel? For second degree, that is 1/3 ng base times the height. So can we use that, guys? Take note, hindi siya always na ginagamit directly. May limitation yun. Anong limitation nun? Dapat yung endpoint ng spandrel must be katapat niya yung vertex ng diagram above. Okay, so ito yung spandrel na pinag-usapan. Check mo yung diagram above. Kapag yung itong vertex, no, na tinitingnan mo dun sa spandrel is coinciding do sa vertex ng diagram above, therefore, we can use yung area ng spandrel. So in that case, madali pa. We can solve this one, 1/3 base times the height plus area ng rectangle. So whatever is the area that is positive, so ipa-plus natin siya negative 60. So let's say for example, hulaan ko na lang, halimbawa, nung pinlas ko, naging positive yung value. Kunwari lang, hindi ko sure. So for example, napunta siya dito. So paano natin ko-connect yan, guys? Paano i-connect? Kung second degree, plus 1 degree siya, so third degree. So as you can see, nag-start siya dito from 8, nagtapos siya 20. So, increasing. So therefore, concave upward pa rin. So, ganito siya i-connect, ganyan, na third degree. Okay? So from this point, pag may value ka na niyan, so paano tayo mapupunta dito sa point na to after 7 seconds? So what we need to do is to just add yung area nito, guys. Which is madali, no? Trapezoid. So this point plus the area of this trapezoid, let's say for example, napunta na siya dito, umangat, kasi positive yan eh. No? So kung first degree, second degree ang pang-connect ko. Tama? Kung first degree ito, second degree dito. So nag-start ng 20, napuntang 38, increasing, so concave upward. Ganyan. Na second degree, lagay natin. Okay? So ito yung magiging mahirap dito, guys, no? Kasi as you can see, dito sa point na to kasi, nagkaroon ng transition, no? From positive area, which is ito, positive area, nagkaroon ng negative. We know na kapag nagpupunta sa point na nagsisiro, no? Meaning yun parang yun yung yun yung highest point, di ba? Kung pag-usapan natin yung calculus. So, meaning to say, we have to determine first, no? Yung position na to. Yung time na to, rather, no? At what time, no, magkakaroon ng transition from positive na naging negative. Take note, class, ano ba yung ibig sabihin ng negative na velocity, guys? Negative velocity means na aatras siya, no? Meaning to say, from that position, maging pababa yung yung graph natin siya dito sa sa position time diagram. As you can see kasi dito, no, papanik siya ng papanik. Palaki ng palaki yung position niya. So after this one, aangat pa ulit yan. And then at this point, bigla na siyang bababa. No? Kasi negative na yung velocity. No? Umaatras siya kumbaga. Gets ba yun, guys? So yun yung isang magiging obstacle natin dito. Kasi we must first know ano ba tong point na to. Bakit? Kasi magiging reference natin yun para kunin yung area neto eh. Okay? So let's say for example, nakuha na natin yung yung time na to. Yung time na nag-zero yung velocity or yung time na nag-transition from positive velocity na naging negative velocity. O paano kukunin yung area neto, guys? Oy, second degree. 1/3 base times the height. But the problem here is that applicable ba yung 1/3 base times the height na yun? So let us verify. So di ba parang ito yung lumalabas na vertex na itong spandrel? Itong spandrel, guys, ito yung lumalabas na vertex. Pero vertex ba talaga yan? So, titingnan mo yung sa taas, di ba? Yung katapatan niya. Kapag vertex yung katapat niya, therefore, totoong vertex siya. Kapag hindi, hindi siya vertex. So, as you can see, hindi naman vertex yung nakatapat niya, di ba? Ayun, oh. Oh, may height nga dyan, eh. So, therefore, hindi siya vertex. At dahil hindi siya vertex, hindi magagamit directly yung 1/3 base times the height. Okay? Hindi mo magagamit, guys. So, hindi magagamit, paano ka makakapunta dun sa point na yon? Paano mo makuha yung point na to, no? Kung hindi mo kayang kunin yung area. So, yun yung downside netong solution na to, no? Na kailangan sure tayo sa pagkuha ng area. Okay, tama yung area ang kinukuha natin. Okay, so let's say for example, nakuha mo na yung area. Magaling ka, marunong ka. Ayun na siya. Ito na yung point, no? So, from this point, plus yung area, mapupunta ka na dito. So, how do we connect? Kung second degree yan, guys, di third degree. Hindi dito. So, what type ng third degree? Increasing slope or decreasing slope? So, as you can see, nag-start ka from 38. Nagtapos ka ng 0. Diba dito? So, from 38 naging 0, decreasing. So, yung decreasing na curve is pag ganito naman yun, diba? From positive slope, naging negative yung slope. So, concave downward. So, ganito siya i-connect. Ayan. Pag ganun yung curvature. Okay, so lagyan natin ng legend. This one is third degree. So, next. Ito naman. Paano to? Paano kukunin yung area na ito? Nung negative area na yan. So, pwede ba dyan yung 2/3 ng base times the height? Since yan yung parang kabaligtaran ng spandrel, di ba? Ayan. 2/3 base times the height. Pwede ba yun, guys? Kasi second degree pa rin naman yan. Continuation. So, let us check kung pwede. No? Kapag tinignan mo yung point na to, yung katapatan niya sa taas, ayan, no? So, nakita niyo ba yung sinusulat ko? Ito na lang. Hinighlight ko. Yung katapatan niya, class, hindi na naman ng vertex, oh. So, therefore, we cannot directly use yung 2/3 base times the height. So, sana nagigas nyo yung idea, no? Hindi pwedeng gamitin yun, guys. Not unless kaya mong kunin yung neto. May diskarte kasi niyan, guys, eh, no? I-highlight ko ng red. So, gagawin ko, kukunin ko yung continuation nito kung kailan siya magsi-0. Tapos, i-straight ko siya dito ganyan. Okay, tapos saka i-continue tong curve. Parang igaganyan ko. Tapos gagawan ko ng konting analysis ng geometry plus minus ng area. Basta ang sure ko, ito yung vertex. Ayan. Kita ba yung sinulat kong vertex na yan? Ayan. Ayan yung sure na vertex. Yung continuation nung second degree na yan. Bakit? Kasi pag tinignan mo nga sa taas, ayan yung karugtungan niya. Oh. Tugma na vertex ng triangle. Gets ba yan? So, ganun siya. Pwede yan, guys. Nagawa ko na yan. Pero, hindi ko napapakita kasi nga ang haba ng solution na yan, guys. So, anyways, let's say for example, kaya mong kunin yung area. So, from this point, minus yung area na yan, since negative. So, pababa. Pupunta ka dito. So, how do we connect? Since itong straight na to, di ba parang isang curve lang yan na second degree. So, meaning to say, isang curve lang din to na third degree. So, continuation lang siya na concave downward. Okay? Gets ba yun, guys? So anyways, yan lang naman is kung halimbawa ang problem is tinatanong, which of the following is the correct representation of the position time diagram? O ayan na siya. No? Yan na yung correct na pagdodrawing ng position time diagram. But in this specific problem, hindi naman natin tinatanong yan, yung curve. So anyways, pinakita ko lang kung magiging gano'ng kahirap, no? Gamitin yung napag-usapan nating unang method. So ngayon, gamitin natin yung second method, which is yung moment area method, no? Okay lang? So let's start, guys. So let's say for example, number 33 muna tayo. So ang tinatanong is yung position niya at time is equal to 7 seconds. So meaning to say, kung gagamitin natin yung graph, dito tayo magtitingin sa taas. So, ano yung magiging point 2 natin, guys? Di ito yung point 2 natin. Diba? yung at 7 seconds, and then ito na lang gamitin natin 0.1, yung initial. Okay lang ba guys? Gets pa ba? So, lagay muna natin. What is T1? 0. What is V1? Ano yung velocity niya initially? Hindi 0 yan guys. Nag-start siya ng meron na siyang 8 feet per second. And then ano yung S1 guys? Hindi rin 0 yan guys kasi sinabi nga 60 feet to the left of the origin siya. No? Nag-start siya at negative 60. Okay, so yung tinatanong natin yung at point 2 na after 7 seconds. Ano yung S2? So we are now complete now with the parameters. No, pwede nating directly gamitin yung formula. S2 equals S1 plus V1t plus the area moment of the acceleration time diagram. So that is S2 equals negative 60 plus V1, nag-start siya at 8. Ano yung time interval T? So that is T2 minus T1. So that is 7 minus 0 plus area moment. So ano yung pinag-uusapan nating area dito? Yung area between time interval. Ito lang guys. Yan lang. Yung triangle saka yung rectangle. Okay? So, kunin na natin isa-isa. Or meron na. Ayun pala. Meron na tayong area ng triangle. 12. Area ng rectangle. 18. So, kailangan na lang natin yung kunin yung moment arm. So, what is the moment arm nun para sa triangle, guys? Ito. So, that is ito. So, sana clear pa yung drawing, no? So, ito 3. Diba 3 to? Tapos, ito 4. So, that is 1/3 nung 4 plus 3. Okay lang? So, lagyan na natin dito sa baba yan. The area is 12. And then, the moment arm is 1/3 nung 4 plus 3. And then, plus yung rectangle. The rectangle has an area of 18. The moment arm is what? Okay, so zoom in natin para nagigets. Ito yung centroid. So, ito yung moment arm. So, of course, kalahati ng 3 yan na 1.5. Okay? So, 1.5. Okay, so with that, makukuha na natin yung S2. So, nagets ba yung equation natin? So, S1, V1t, area ng triangle times the moment arm, area ng rectangle times the moment arm. So, paki-input sa calculator how much is the S2, guys. Okay, so from my calculator, ang lumabas na sagot is 75 and then the unit is in feet. So as you can see, from the choices, we are correct. Check yan guys, check. So nakita mo, ang gano'n siya kabilis guys, ayun o, equation lang. So long as kaya mong interpret yung acceleration time diagram. Okay? So let's proceed dun sa last item. Number 34, no? When time is equal to 13 seconds. Okay? So dito, obligado tayo na gamiting 0.2 yung 13. Okay, siya yung 0.2 mo. Kasi yan yung hinahanap eh. Ano na daw yung position niya after 13 seconds. Ngayon, you can use ito as your 0.1. No, pwedeng yan ulit. So, gagayahin mo na lang to. T1 0, V1 is equal 8, S1 is negative 60. Okay, tapos ang area moment mo is yung lahat ng area na to guys. In between 0.1 and 0.2. Lahat yan, imo-moment mo at 0.2. Kasi as you can see, masyado yung matrabaho guys. No? Masyado siyang matrabaho. So what I can do is to use yung nasolve ko na before, itong S2, or yung S at 7 seconds, no? Pwede ko siyang gamitin as my new initial point. Guess nyo ba yun, guys? Imbis na ito yung initial point ko, ito na lang. Para maliit na lang yung area na imo-moment ko later on. Okay? Kasi nga 'di ba kanina pinakita na natin na you can use any point, no, within the curve as your point 1 so long as kaya mong kunin yung velocity at that point and then yung position at that point. Okay? So, pero pwede mo i-try ito, guys, ha. Ikaw na lang mag-try on your own. Mag-start ka dito. Ito yung gamitin mo yung point 1. Tapos i-moment mo lahat. Okay? And then verify kung tama at parehas yung sagot. Pero for the meantime, ang solution ko, dito na ako mag-i-start at 7 seconds. So, mangyayari, yung T1 dito, 7. Ano yung S1? Ano na yung S at 7 seconds? Di ba nasolve na natin yun? Ito nga yun, no? Di ba? 75 feet. So, 75 na lalagay ko dito. O, ano na yung velocity at 7 seconds? So, we can use na lang dito, yung drawing na to. So, nasan yung 7 dito, guys? Ito yung 7, no? So, ito yung velocity, guys. So, 38. Okay lang. At 7 seconds from the graph, the velocity is 38 feet per second. So, lalagay ko na yung 38. Tapos, ito na yung point ko. 13 seconds. What is its position? S2. Okay? So, gamitin natin yung formula. S2 is equal to S1 plus V1t plus the area moment of the acceleration time diagram. So, nag-start tayo. Nasa 75 na siya. Plus 38. Ano yung T? T2 minus T1. So, that is 13 minus 7. Okay, plus. So, ito na lang yung area natin, guys, no? Na pinag-uusapan. So, hatiin na lang natin to into two area. Isang rectangle saka isang triangle. Okay? So, kunin muna natin, guys, yung area. So, yung base niyan is 6, di ba? So, take note yung height na to. Ito is 3. So, ito magiging 9. No? Lagyan natin negative 3, negative 9. So, area ng triangle, 1/2, base is 6, height is negative 9. So, that is negative 27, I think. So, ito is area ng rectangle, base times the height, 6 times negative 3, negative 18. Okay, so start tayo sa rectangle. So, area is negative 18. Anong moment arm? So, centroid, papunta dun sa point 2. So, this one is 3. So, negative 18 times 3. Plus, yung area ng triangle, negative 27. Moment arm is what? So, ito yung centroid. Moment arm is ito, no? Which is 2/3 ng base na 6. So, that is 4. So, times 4. Okay? So, with that, masolve na natin yung S2. So, how much yung S2, guys? Okay, so lumabas sa calculator ko, S2 equals 141 and then the unit will be in feet. Okay, so let us check if we are correct. So, we are correct. No? 141. So, check. Okay, so yun lang yun, guys, no? So, I hope na nagets ninyo kung paano gamitin yung moment area method and then ma-apply nyo siya sa mga problems, no, na possible na lumabas sa board exam. So, yun lang, guys. So, hanggang dito na lang yung ating discussion. So, see you on our next video lecture and God bless, guys.